Primera, we spoke about this last time in the previous video. Please check out the next and the previous video for more details on this. I just want to go back and start with this first, actually, which is number 11. I want to start with number 11 first. Now, in number 11, you need to remember, guys, when you multiply same bases, you always add the exponents. And when you add a negative exponent, that negative exponent will just be minus. So if I have 5 plus negative 3, that is the same as 5 minus 3, and 5 minus 3 will be 2. But you only add the exponents when you multiply the bases that are the same. Remember that. Let me go to, please guys, go through this before your exams and you'll be fine, trust me. For number 11, the base there is 3, 3, 3. So it's the same base. That dot in between represents multiplication. So when you multiply the bases that are the same, you will simply have to add the exponents, okay? So since I've got 3 here, and I've got 3 there, and I've got 3 here, I will have to add the exponents. And since we're multiplying, I have to add the exponents. Now, when you add the exponents, remember this, they must be like terms. The first term there, which is x, is x plus 2x minus 3x. So 1x plus 2x's, what do you get? You'll get 3x's. 3x's minus 3x's, what do you get? You will get 0. So you will end up having a base of 3 raised to the exponent of 0. And with exponents, anything raised to the exponent of 0 is 1. Do not forget that. Okay. Everything raised to the exponent of 0 is 1. Right. Let's check the next one, number 12. Again, here I've got the same base. It's 2 times 2 times 2 times 2, all right? So I'm going to write it as a single base, but what do I do with exponents? I'm going to take the exponents. So the first exponent is x, so x plus 5x's. 1x plus 5x's gives you how many x's in total? It gives you 6 x's. Then take your 6 x's, x's and minus 4 x's. What do you get? 6 minus 4 leaves you with 2 x's. But I cannot add the last exponent. Why can't I add the last exponent? Why cannot I add this here? It's because it doesn't have x. So my answer here, when it comes to the exponents, I'll have 2x's minus that 2. I cannot add that minus 2 with the x because they are not like terms. Okay, that is why I only have 2 to the exponent of 2x minus 2. And there's nothing I can do with these two because they're not like terms. The second term, which is that negative 2, it doesn't have x in it, so I cannot add it or subtract it. Okay, let's move on to the next one. I included this in one of the tests, and the kids were like, wow, how do we do that? I don't know what happens when you guys are writing exams. It's like everything that you have learned in class just goes out. Now, let me see. When you multiply here, I'm going to start by multiplying the numbers first. Negative 4, because they're not same bases, so I can just multiply them, okay? Negative 4 times 3, and then times it by negative 2, okay? And then I'm going to multiply the x's first, which is x to the exponent of 1 times x to the exponent of 1 times x to the exponent of 2. That will give me x to the exponent of 4. Correct. Let's go to the y's. I've got y to the exponent of 1 times y to the exponent of 2 times y to the exponent of 2. What does that give me? Y to the exponent of 5. Okay, so that's what I did. I multiplied the numbers first and multiplied the x's together, I multiplied the y's together. Do you need to do this step? The answer is no. But here I'm just breaking it down to show you how I did it. Okay, so what is minus 4 times 3 times minus 2? So minus 4 times 3 times minus 2, what does it give you? Minus 4 times 3 will give you minus 12. Minus 12 times negative 2. So negative 12 times negative 2. Negative times negative is positive. And then 12 times 2 gives you positive 24. What about the x's? What are we going to get when we multiply the x's together? This x has an exponent of 1, we do not write it. This x has an exponent of 1, we do not write it. And this x has an exponent of 2. Okay, so 2 plus 1 plus 1, that gives us 3. So you will have x to the exponent of 4. Now you understand how I got that x to the exponent of 4. Let's go to the y's now. Let's go to the y's. Now we are going to multiply the y's. It's the same base. When you multiply the bases that are the same, you add the exponent. So this y has an exponent of 1. And the second one has an exponent of 2. The third one has an exponent of 2. So we are going to add 1 plus 2 plus 2. 1 plus 2 gives you 3 plus 2, it gives you 5. You will end up having y to the exponent of 5, and that is your final answer. 24x to the exponent of 4, y to the exponent of 5. All right, excuse me. Let's go to 14. 14 we are multiplying, right? But now, in between the multiplication, there's a plus. We're not multiplying the positive 3, no. There's a plus in between, meaning that we are adding. So what am I going to do? I'm going to multiply these ones first. I'm going to multiply these ones first and multiply the last term after I multiply the first one. Multiply the yellow ones first. So that is the first term. Terms are always separated by plus or minus, okay? You will learn that later on. So when I multiply the first term, so I've got 2, so I don't have any other number there, so it'll just be 2. What about the x's? How much will they give me? They'll just give me x to the exponent of 4, and then y, right? Then I've got plus in between. The next ones, what am I going to get? The green ones. 3 x to the exponent of 4 y. So this is what you will get. You will notice that these terms are like terms. Okay? Like terms are terms that have the same variables. I mean, they have the same variables, yes, and the exponents of those variables must also be the same. Okay, let's check if that is true. This is 2x to the exponent of 4y. Do we have x to the exponent of 4y there? Yes. I mean, in the first term, x has an exponent of 4, y has an exponent of 1. In the second term, x has an exponent of 4, y has an exponent of 1. So these are like terms. When you are adding like terms, you keep the variables and their exponents the same. You just add their coefficients. Coefficients are just integers multiplied by those variables. So I will just add this 2 with this 3 because why am I adding? Because we've got plus in between. That's why I'm adding. 2 plus 3 will give me what? It'll give me 5. But check, x to the exponent of 4 and y to the exponent of 1 still remains. You just add the numbers, which are your coefficients. But you can only do this if the variables are the same and the exponents of those variables are also the same. So each term must have the same variable with the same exponent and the same variable with the same exponent for you to be able to add or subtract them. We good? Great. Let's go to 15. How many terms do I have there? I've got only 2 terms, okay? This will be the first term. Remember, I told you earlier on, terms can only be separated by minus or plus, and this will be the second term here. This will be the second term here. So this will be the second term here. Okay, the yellow ones, what am I going to get when I multiply them? Multiply the same bases, you add the exponents, right? You only add the exponents when you multiply the same bases. Okay, not when you add same bases. You see in number 14, we multiply the same bases, but then in step 2, we were adding. Someone is confused. Probably someone is like, yeah, why don't we have x to the exponent of 8? No, it's because we are adding in between. You only add the exponents only when you're multiplying, not when you are adding or subtracting. So the yellow ones, I'm multiplying them. The green ones, I'm also multiplying them. And since I'm multiplying them, what am I going to do? I'm going to write it as a single base, which is p, and then I'm going to add the exponents. Okay, you multiply before anything else. So that's what I'm going to do. I'm going to multiply first, and this is what I'm going to have. Now that I've multiplied, I realize I'm subtracting this 2. 1p to the exponent of 4 minus 1p to the exponent of 4. What do you get? You will get 0. You will get 0p to the exponent of 4. But anything you multiply with 0 is 0. Please don't confuse this with the exponent being 0. This is not the exponent. It's basically when you minus your bases, your answer is 0. But when your exponent is 0, your whole power will be 1. Just remember that. Okay. I hope you learned there. You're clever now. You're smarter, right? All right. Let's move on. Try this exercise from your mind-born textbook and make sure that you do the exercises first and then you mark yourself afterwards, okay? And then watch the videos. I've already opened the videos. For those that don't have Mindborn, if your school is using Mindborn, make sure that you get it. Wow, I'm giving them free air now. Hope they'll come back and advertise here. Just remember to watch the videos. They're already open. They're good videos, to be honest. All right. Then I'm going to move to this here, exponential laws of division. When you multiply, or actually when dividing powers with same bases, you must subtract the denominator exponent from the numerator exponent. This theory comes from the fact that division reduces the number of times the base is multiplied by itself. Okay, for instance, if I've got 4 to the exponent of 3 divided by 4, I end up having 16. And you will note that that 4 to the exponent of 3 has now been reduced to only 4 to the exponent of 2. Why is that the case? It's because of that when you ask to expand, this is what you will have. And then obviously you're allowed to cancel the bases if they have the same exponent. And you end up having only 4 times 4. Do you see that by dividing the numerator with the same base, it resulted in you having lesser of the numerator bases. Before we had 3 bases of 4. And because we divided by 1 base of 4, we are only left with 2 bases of 4. And that's why we have our answer as 16. Here, division by the same base reduces the number of times same bases are multiplied. As specified, exponents indicate how many of the same bases do you have multiplied. Here, the number of same bases multiplied is decreased, hence it makes sense to reduce the number of these bases as division by the same base resulted in less bases being multiplied. Okay, let us look at this here. 15. X to the exponent of 15 divided by x to the exponent of 11. You will write it as x, but you will take 15 minus 11. 15 minus 11 will give you an exponent of 4. So when you divide same bases, you just subtract. You keep the base, you just subtract the exponents. Let's go to number 2. I'm dividing same bases, so I'm going to write it as the same base and subtract exponents. Same with number 3. Number 4, I might have to multiply first before I even try to divide. Number 5, I'll have to multiply first before I even try to divide. Even with number 6. Okay. Let's go through those quickly, right? Let's go through them quickly. Let's go through them quickly. What do we have? I did this for you already, right? What about this? What did you guys get here? I'm dividing same bases. I'm going to take the bigger exponent here, which is 5. And then I'm going to minus the 3. So whatever answer I get, the base will be in the numerator because that's where the bigger exponent is. The base will still be in the numerator, but the exponent of that base will be 5 minus 3. That is because 5 is bigger than 3. So your base will be 3 to the exponent of 2. How did I get that 2? It is just 5 minus 3. Why is it that this 3 is not in the denominator? It is because the base that has the bigger exponent was in the numerator. Okay, let's get to this one here. I've got x in the numerator, and I've got x in the denominator. The x in the numerator has the bigger exponent, so whatever I get here, my base will be in the numerator because the exponent of x there is 5. What is 5 minus 3? It is 2. Let's go to the y's now. I've got y in the numerator. I've got y in the denominator. The bases are the same. What must I do with the exponents again? I'm going to take, so my y will still be in the numerator here because the y in the numerator has a big exponent. I'm going to take that 4 and minus this 2 here. So I'll be left with y to the exponent of 2. You can say divided by 1, but obviously anything you divide by 1 is just that thing. Okay. So all of this will be in the numerator. That's why you realize that I don't even have a fraction anymore because everything is in the numerator, meaning that I'm left with only 1 in the denominator. Everything you divide by 1 will just be that. Okay. All right. Let's move on. Wow, what do I do here? What am I going to do? Where do I even start? Okay, start with the numerator. Work with the numerator separately and then work with the denominator separately. And then you can apply the laws of division. Basically, I'm going to apply the laws of multiplication before I apply the laws of division. Okay, let's check what is it that I've got. I've got here m to the exponent of 1 times m to the exponent of 1 times m to the exponent of 2. What will that give me? it'll give me m to the exponent of 4. When you multiply the bases that are the same, you just add the exponents. Now, I've got here n to the exponent of 1 times n to the exponent of 1 times n to the exponent of 1. What does that give me? It'll give me n to the exponent of 3. That's why I've got this over here. When you're dividing the bases that are the same, and the exponents of those bases are also the same, all you can do is just to cross them out, okay? Or you can apply the laws of division, which says that write it as a single base. So I'm going to write it as m, and then I'm going to take the smaller exponents, minus it from the bigger exponent. So your answer will be in the numerator. Now, what if the exponents are the same? Okay, your answer will still be in the numerator here, okay? Or you can just cross them out like I've done. So you will say 3 minus 3, which is 0, and this is what you will have. And this will give me m to the exponent of 1 times n to the exponent of 0, but n to the exponent of 0 is 1. 1 times m is m. So that is your final answer. Let's get to this one here. You will start with multiplication again. N to the exponent of 3 times n to the exponent of 11. You will write it as n and then add the exponents. Why do I add the exponents? It's because I'm multiplying the same bases. This will give me n to the exponent of 14. I still have n divided. So I'm going to take the bigger exponent, which is 14 minus the 3. So my answer will be in the numerator, which will be n to the exponent of 11. All right. Now that I've gone through that, please try this on your own. Oh my word, gave you the answer there. Okay. I'll just continue. Here I apply the same principles, okay? I wanted to give you that as just a classwork. All right. Fortunately, I ruined it there. All right, let's look at this here. What are we going to get? In the numerator, you will have x to the exponent of 3 times y to the exponent of 3 times x to the exponent of 6. Okay. These are the same. So what must I do with exponents? You add the exponents. Even in the denominator, these are the same. What must I do with the exponents? You add the exponents. Just remember that this y here has an exponent of 1. There's 1 there. There's 1 there. Just that we don't write it. So in the numerator, you'll have x to the exponent of 3 plus 6 times y. In the denominator, you'll have y to the exponent of 2 plus 1 times x to the exponent of 5. This is what you will have. Now that we've got the same bases with the same exponents, you just cross those out. But here we've got the same bases with the same exponents, so I can't cross them out. Instead, I will write it as a single base and just take the bigger exponent, which is 9, minus the small exponent, which is 5. But because 9 is in the numerator, our answer will be in the numerator, which will be x to the exponent of 4. Okay. Try this one. Give yourself 15 minutes to do all of these, all right? And then press play to get your answers. I'm dividing bases that are the same. I'm going to write it as a single base, which is 2, and then I'm going to say 5 minus 2. It'll give me 2 to the exponent of 3. What about the x's? I have the bases that are divided that are the same, so I'll just take the 5 minus the 2, which is x to the exponent of 3. What about the y's? Same bases. The denominator y has an exponent of 1, so I'll just say 7 minus 1, which is 8, and this is what we'll have. 7 minus 1 is 6. However, please note, this 2 to the exponent of 3 is actually 8. Awesome, isn't that awesome? Math is awesome, guys. Math is refreshing. Okay, it's lovely. Too bad people prioritize mjolo and alcohol when there are beautiful things like math. It's just refreshing. It exercises the mind. It's yeah, instead of going to a spa, massage spa, I would actually do math, okay? Because it helps you think better. It helps you relax. It's a beautiful subject. Okay, let's go to this one here. Now, please note, someone might say, but in the numerator there, we do not have multiplication. Please note that you can just put the multiplication there, okay? They're stacked together. Just know that they're multiplied. All right, so it's just multiplication. So it's a to the exponent of 3 times b to the exponent of 6 times c to the exponent of 5 times c to the exponent of 4. Now, everything doesn't matter. What matters the most is the c's. Why? Because they are the same bases. If they are the same bases, we just need to add the exponents. Do you see now? I'm now having c to the exponent of 9. How did I get this 9 here? I added 4 with 5. So 5 plus 4 gave me 9. Now that I have simplified this, same bases. This is the same base, a. There's another base of a in the denominator. So I can subtract the exponent. So the a will move to the numerator, and then I'm going to take 3 minus 2. What about the b's? The numerator b has an exponent of 6. The denominator b has an exponent of 13. That means this numerator b moves to the denominator. So our base b will be in the denominator because the denominator b has the higher exponent. Okay, so instead of minusing 13 from 6, I'm going to minus 6 from 13. So I'm going to keep b in the denominator, meaning that in the numerator I'll only have a and c. B will still be in the denominator because the denominator b has a bigger exponent. Awesome, isn't that? So you will have 13 minus 3 because 13 is bigger than, it's 13 minus 6. That is because 13 is bigger than 6. That's why you keep the b in the denominator where the exponent is higher. 13 minus 6 will give you 7. Awesome, isn't that awesome? Told you, math is lovely. It's the only subject actually. Well, not to talk bad about accounting, but yeah, without math, there wouldn't be accounting at all. Without math, there wouldn't be physics at all. I wonder which one came first. Is it science or math? Philosophy or math? The egg or the chicken? All right, let's move to this one here. I've got a base of 3 there. I've got a base of 3 there. I've got a base of 3 there. Isn't that good? Now I'm going to add the exponents because I'm multiplying. Multiplying, you add the exponents. When you multiply, you just add the exponent. But I notice something here, that this exponent here is different. It doesn't have x. So I can only add the first two exponents, which is 1x plus 2x. That will give me 3x plus 5. I keep the 5 there. Okay. And then I realize that I've got 3 here. I've got 3 there. So that one cannot make me decide which exponents I'm going to subtract and where I'm going to keep my base. But this here will, however, help me determine whether do I subtract from the numerator or do I subtract from the denominator? 5 is bigger than 4. So here I have to subtract from the numerator. So I'm going to take this whole fraction and minus this whole fraction. I mean, minus this whole exponent. Sorry for that. So that 3x, when I minus it, it will be negative, and the 4 will also be negative when I subtract them. Oh, okay. Now, 3x minus 3x will give me 0. 5 minus 4 will give me 1. I'll end up having 3 to the exponent of 1. And 3 to the exponent of 1 is just 3. Good, right? That is great. Don't you think? It was. All right, let's move on. Right here. Same base, same base, same base. You add the exponents. Now I'm dividing same bases, but the base with the big exponent is the one in the numerator. So I'm going to keep my base in the numerator. And then the base in the denominator has an exponent of 1. So it'll be 14 minus 1, and I'll keep it in the numerator, and that'll give me 13. All right. Try this out. Pause for 45 minutes and do that activity. After 45 minutes, just press play, and these will be your solutions. Fifteen goes into 30 twice there. That's why we have the 2. Instead of doing this, you could have just done this. Same bases, same exponents, you just cross out. So you move from there to this point here. You don't need anything in between. Okay. Yeah, I just crossed out. All right. Try these exercises and make sure you watch the video. Okay, mind born. Page 66 is 3.4. Okay. Please write these notes and check out the next video. Actually, let me do it now. Okay, let me just do it now. All right, we're dealing with distributing exponents. Distributing exponents is all about multiplying exponents. Similar to distributive law, learned up to this point. However, here we are not distributing bases. we are distributing exponents, that is multiplying exponent with exponent. For instance here, please note that you can distribute and multiply exponents only across multiplication and division. You can only multiply exponents only across multiplication and division, meaning that you cannot multiply exponents across addition or subtraction. I'll give you one example shortly. For instance here, I've got a to the exponent of m divided by b to the exponent of m. So divided. If it's divided, I can just multiply the exponents. So m times 2 will give me 2m. That is for the numerator one. For the denominator one, I'll have m times 2, which will also give me 2m. That's why I've got a to the exponent of 2m divided by b to the exponent of 2m. The principle behind this is that both the exponent of the numerator and the denominator must be multiplied by 2. The rules do not change. Before you distribute, remember to simplify what is inside the brackets first. Please take note. You may not distribute exponents across addition or subtraction. You may only distribute exponents across multiplication and division. For example, here I have multiplied, so I can distribute the exponents. I can take this 2 multiplied with this exponent, which is 2m, and take the same 2 and multiply it with this exponent, which is 3n. And that is because in between I've got multiplication. I'm allowed to do this if it's across multiplication or division. So 2 times 2m will give me 4m, and 2 times 3n will give me 6n. All right, let's move on to the next one. Here. And this one, and this one, and this one, and that. We're going to go through all of this. Can you believe it? Okay. Here, please note that I can distribute because they're multiplied inside. So I'm going to distribute. A lot of kids left out this exponent here. There's one there, people. So it'll be this 2 times that 1, and the same 2 times this 2. Remember, we're just multiplying the exponents here. We're distributing exponents. And this 2 times this 3. So your answer will be 2 to the exponent of 2 times x to the exponent of 4 times y to the exponent of 6. That's all. But 2 to the exponent of 2, how much is that? It is just 4. Great. Let's move to the next one. What is the answer here? I'm going to get 3 to the exponent of 3, a to the exponent of 15, and b to the exponent of negative 6. Negative 2 times 3 will give you negative 6. Now, 3 cubed will give you 27, but immediately when you realize that the base has a negative exponent, you will take the base the whole base and its exponent to the denominator. If the negative was in the denominator, you take them to the numerator, okay? So those 2, I'm going to take them to the denominator, and the rest will be left in the numerator. So b and its exponent of 6 will go to the denominator. Okay, so in the numerator, I'll only be left with 3 and a. But note that 3 to the exponent of 3 is 27. So I'll be left with 27, a to the exponent of 15. But b and its exponent will go to the denominator just because the sign of the exponent is negative. Okay. For instance, if I had, let's say I had a to the exponent of 2 divided by b to the exponent of negative 3, the solution to this was going to be a to the exponent of 2, but this b will go to the numerator because the exponent of b is negative, so it'll just be there in the numerator, so it'll be b to the exponent of 3, so the negative is gone. But in the denominator, because I've moved the b and its exponent to the numerator, I'm just left with 1. And anything divided by 1 is that thing. So I'm still having that a to the exponent of 2 times b to the exponent of 3. Okay. What about you? Remember, simplify what is inside the brackets first before you distribute the exponents. So when I simplify what is inside the brackets first, this is what I will get. When you divide bases that are the same, you always minus the exponents. I don't think I need to explain that. Here, the exponent is 1, the exponent is 1, the exponent is 1. All those ones must be multiplied by this 3. Okay, all those ones must be multiplied by this 3. And this is what you will get. But 2 to the exponent of 3 is 8. So I'll be left with this. Great, isn't it? Awesome. Okay. Well, guys, this one we have done it so many times. I'll just go straight to the answer. 81 is just 3 to the exponent of 4. What is the answer here? R to the exponent of 15, S to the exponent of 3, T to the exponent of 6. Don't be fooled here. Only the exponent is raised, only the numerator is raised to the exponent of 3, not the whole thing. A lot of people will go and simplify. No, here you can't simplify because only the numerator is raised to the exponent of 3. So you will just distribute this 3 only to the numerator, okay? Only to the numerator. So in the numerator, we'll have m to the exponent of 6 times n to the exponent of 9. That is different to when this was the case, where we had m to the exponent of 2 divided by n to the exponent of 3 divided by m to the exponent of 4 times n to the exponent of 3. If this was the case, and all of this was raised to the exponent of 3, if this was the case, then we were going to have to work what is inside the brackets first. And then with the m's, I will have 1 in the numerator because the m in the denominator will have the bigger exponent, and in the denominator I'll have m to the exponent of 2 because you always subtract from the bigger exponent. Then you're going to have 3, and then you're going to distribute the exponent of 1 there is 1, the exponent of m in the denominator is 2. Both of them must be multiplied by 3. This must also be multiplied by 3. You were going to end up having 1 divided by m to the exponent of 6. Okay, that is if the whole bracket was cubed. Right here, it's not the whole fraction that was cubed. It's only the numerator that was cubed. It's only the numerator that was cubed, not the whole fraction. Okay, now when you apply the rules of division there, you'll end up having m to the exponent of 2 and to the exponent of 6. Okay, done. What about this one here, and this one here, and this one here, this one here, and this one here? I just want to give you these heads up here. If inside the bracket you have a negative base and your exponent is even, that negative base will come out as positive. If you have a negative base inside the brackets and your exponent is odd, that negative base will still come out as negative. If you have inside the bracket a positive base, but outside the bracket you still have negative, you'll still have that positive base, but because of the negative, it'll just be negative because the negative is outside. So the exponent does not influence the sign here. So this is outside, it's not raised to the even exponent. That is why the even or odd exponent does not affect the answer, unlike the first two. Okay. How would you work this one out? Work what's inside the brackets first, then distribute. 8m times 2 will give you 16m. 3n times 2 will give you 6n. This is what you'll end up with. What about here? You will have this. And then simplify and have this. And then distribute and have that. So you simplify what is inside the brackets first before you can distribute. 5 times 4 will give me 20. 5 times 5 will give me 25. Okay. Moving right along. What about this here? You just distribute the first, this times that. This is 1, so it'll be 2 times 1 and 2 times 5. And then you go to the next one, it'll be 3 times 3, 3 times 5. We've got 1 here, and then you'll say 3 times 1. Sorry, 3 times 1. Okay, and this is what you will end up having. These are numbers, so we just multiply them. What about the m's? M's will be raised to the exponent of 17. And n's will be raised to the exponent of 13. So this is what we will have. How did I get 81? 81 is just 3 to the exponent of 4. It's 81. I'm multiplying it by 2 to the exponent of 9, which is 512. Okay? But remember, when you multiply the bases that are the same, what do you do with the exponents? You add them. So if I multiply this, because I'm multiplying, remember, I'm multiplying, I will just add the exponents. 2 plus 15 will give me 17. Okay. If I multiply this, it'll be 10 plus 3, which gives me 13. Okay. And when you multiply 81 with 512, you will get 41,472. What about here? Aha, you see, we have a negative here, and our exponent is an even number. So that negative will just change and become positive. Okay, and then you apply the distributive property like you normally do. So there is 1 here, there is 1 there, there is 1 there. So you will say 4 times 1 will give you 4. 4 times 1 will give you 4. So I'll end up having 2 to the exponent of 4. And what is 2 to the exponent of 4? 2 to the exponent of 4 times x to the exponent of 4. The thing is, the negative is gone. Why is the negative gone? It's because my exponent was even. So if your exponent is even and the sign is inside the bracket, that negative will change and become positive. That is why I've got this over here. Once you have this, we are multiplying. Brackets mean we need to multiply. So you will take negative 2 times it with 16. Negative 2 times 16 will give you negative 32. What about the x's though? What about the x's? X times x, we need to add the exponents, so it'll be 4 plus 4, so it'll be x to the exponent of 8. So your answer will be negative 32x to the exponent of 8. Let's get to this here. Can this sign change because our exponent is even? The answer is no, because the sign is not raised to the even exponent. So if it was here, then it was going to change, but it's not there. So it will remain outside. It's not going to change. It'll still remain negative. That is why here your answer will just be p raised to the exponent of 20. How did I get the 20? It is just 4 times 5. 4 times 5 will give me 20. All right. Just remember this, guys. Anything with an exponent of 0 is 1. So 10,000 to the exponent of 0 is 1. Whatever is inside the brackets, as long as it's raised to the exponent of 0, it will be 1. Whatever is inside the bracket, whether divided, as long as it's raised to the exponent of 0, it will be 1. Okay, you can try these exercises from Mindborn. And next time we will deal with surds. This is more relevant to grade 9s to 12. Okay, guys, if you need extra lessons, please feel free to contact any of those people. Unfortunately, I do not provide math extra lessons, okay? I only deal with accounting. It's 300, I think, per hour. Please feel free to contact all those individuals. They're really, really good, okay? Thank you for watching yet again. Khotso.